Hello, it's Julie Ray, and I'm here to talk about absolute value. I'm going to share my screen with you so that you can see the slides. And let's talk about absolute value. Absolute value is a fairly easy concept. It really is talking about distance. So we can think of sometimes where the direction that we're going doesn't matter. If I am starting in Columbus and driving to Pittsburgh, I know that that's about 180 miles, but I don't think of that as being a positive or a negative number. It's just the distance. You can see that this this map looks almost like a number line. We could think of Columbus as being the 0 point on the number line, and we could think of going to Pittsburgh as being positive numbers, and we can think of Indianapolis as being negative numbers, going in a negative direction. But that's not really how we think about it at all. We think if I'm in Columbus and I want to go to Pittsburgh, it's 180 miles. If I want to go to Indianapolis, it's 180 miles. It's not a positive or a negative situation. It's not even, for the most part, we're not even thinking about whether we're going east or west. It's just the total number of miles. So it's neither positive or negative, it's just distance. And that is what absolute value is saying, is that it doesn't matter if the number is positive or negative. We just want to know how far is it from 0. So it means that the mathematician, let's see if I can get rid of this guy down here. Oh, it means that the mathematician is really only interested in the distance the number is from 0, not if the number is positive or negative. Here. So positive 5 and negative 5 are both 5 units from 0. So if I start at 0 and I go to positive 5, 1, 2, 3, 4, 5 units from 0. Negative 5 is also 1, 2, 3, 4, 5 units from 0. And there are times when I am not concerned with whether the number is positive or negative. I just want to know the distance. Now, I want to make sure that you understand that I'm writing positive 5 here, but really it's the same as this number. This number is also positive 5. We don't write the positive every time we mean positive. We just understand that. So sometimes people say absolute value means that the number is just positive. And that's how it works out when we're doing the arithmetic. But it's important to keep in mind that what we're talking about is that we're just interested in the distance the number is from 0. And we're not concerned about whether it's in this negative direction or in the positive direction. But the way it works out when we're doing the arithmetic of absolute value is that the absolute value of a number is that it is positive. So here we are again. We're starting from 0. Negative 12 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units from 0. And positive 12 is also 12 units from 0. Absolute value is indicated by these signs. There are 2 straight bars surrounding the number. So it looks like vertical lines surround the number, and that's the absolute value sign. -5 and +5. So the absolute value of -5 and the absolute value of +5 are the same. They are 5. It is telling us that they are both 5 units from 0.
This conference will now be recorded.
So the absolute value of -5 and the absolute value of +5 are both 5. So how does that work when we see it in an expression? So if we have the absolute value of -3 plus the absolute value of 5, we just simplify and carry on with the work that we're doing. So the absolute value of -3, remember, we're just talking about how far is a number from 0. I don't care if it's negative in the negative direction or the positive direction. That's not important to me. So it's just 3 plus 5. And then that simplifies to 8. In this problem, the absolute value of -2 times 6, I just simplify. The absolute value of -2 is 2. The absolute value of 6 is 6. And I simplify again, I get 12. Now, in this situation, or in any time, these numbers could both be positive, they could both be negative. You can use absolute value with addition, subtraction, multiplication, division, and fractions, with decimals. The basic concept is the same. We want to know how far is that number from 0. So when would you use this? A lot of times it has to do with science applications, where we're just interested in the change in the value and not in whether it is positive or negative. Most of the time, what I've seen in researching on GED tests, it will come up in something like where you just are going to simplify an expression, or maybe it will be in a formula that you have to use. Let's look at another situation. So if you have absolute value in an expression where you've got an actual math operation, you treat these as parentheses and complete the operation in the sign first. So do what it's telling you, just as if this were in parentheses. -3 plus -17. We know if we start at -3 and we add 17 more negative numbers, we'll arrive at -20. So the absolute value of -20. Now we do that next because we still have these parentheses. We haven't dealt with those. We've simplified the expression inside this absolute value bar, this grouping symbol, and now we're going to do what that is telling us to do. This grouping symbol is telling us to find the absolute value of -20. We know that the absolute value is telling us we're not concerned with the sign, just how far is that number from 0. Well, that number is 20 units from 0. So then after we've done that, we still continue to simplify this expression. 12 times 20. 12 times 20 is 240. So this expression, 12 times absolute value of -3 plus -17, becomes 12 times the absolute value of negative 20 because I needed to do what was in this grouping symbol first. Then I do what that grouping symbol is telling me, which is to find the absolute value of negative 20, which is positive 20. And then I simplify 12 times 20. So this is a problem I found in a GED preparation packet. So I thought this was an interesting one. Plot all the values with the given absolute value. So what that is saying to me is that I need to put a dot on this number line. That's what it means by plot. It means mark or put a dot on all the values with the given absolute value. So what it's asking me is, what numbers would simplify to positive 8 if they were in an absolute value sign? So that means that what numbers would simplify to positive 8? And if I had absolute values of positive 8, I know that would be 8. But also, if I have the absolute value of negative 8, that would also be 8. So I'm going to show you the absolute value of positive 8 and the absolute value of negative 8 are both equal to positive 8. And that's what this question is asking me. What are the numbers that would have the absolute value of 8? Positive 8 and negative 8. So that would end up looking like on this screen, on this number line, is that I would put a dot here, which is negative 8. Oops. So sorry. Put a dot here, which is negative 8. Let me give you a drawing tool here. So see, this is negative 5. So negative 6, negative 7, negative 8. I would put a point here. So sorry for my crazy writing. And then I would put another one at positive 8. If this is 5, 6, 7, 8. Positive 8. Okay, so that's what it means to plot a value, is that you are going to indicate it with a dot. I hope yours look more like circles than mine do. Okay, same thing for 2.5. What are the values with the given absolute value of 2.5? We know that positive 2.5 has an absolute value of 2.5, and we know that negative 2.5 has an absolute value of 2.5. So let's see if we can find 2.5. 1, 2. Obviously, I'm going in the positive direction. And then I need to go 1/2 because this is 3. I'm going to go 1, 2, 3. I want it right between those two. So that's positive 2.5. And then I've got to find negative 2.5. Negative 1, negative 2, negative 3, in between those two. Oops. So this question is actually assessing you on two things. One, do you have an understanding of absolute value, but also do you have an understanding of a number line? And notice they haven't marked all these numbers on here. you have to know that if this is 0 and this is 5, 1, 2, 3, 4, 5, that each one of these marks stands for 1. And you also have to understand that if it gives you a decimal, you have to approximate or estimate the location of that number between the two whole numbers. So if you get close to 1/2 on this, then we would know that you understand those things about a number line, as well as about absolute value. Okay, and now I'm going to go back to my pointer. Yeah, okay. So let's look at the, oops. There we go. So here's another problem that I found on the GED. You can tell because it's very fuzzy when I enlarged it. Which of the following numbers completes the statement, the absolute value of X equals 17? Asking us the same question about plotting those numbers on the number line. The real question is, what numbers, if I put them in the absolute value sign, will equal 17? And we know that if we put positive 17 in the absolute value signs, the absolute value of positive 17 equals 17. So that is correct. But also, if I put negative 17 in the absolute value signs, if I say the absolute value of negative 17 equals 17, that is also a true statement. So both A and B would be the correct answer, because the absolute value of 17 equals 17, and the absolute value of negative 17 equals 17. So both A and B make that a true statement. Which of the following has an absolute value of 1 9/10? Well, see that one of these says something that I know right away will be true. If I put negative 1 9/10 in absolute value signs, I know that will be equal to 1 9/10. That's positive 1 9/10. So for sure, C is correct. But now I have to look at this fraction and say, could that be correct? 19/10? How would I figure that out? Well, I know that this whole number 1, is the same as 10/10. 10/10 is one way of writing 10. I know that any fraction that has the same number in the numerator and the denominator, is equal to 1. Oh my gracious. Here we go. Okay. So there, phew, that was painful. So 1 equals 10/10. That is true for every fraction where the numerator and the denominator are equal. They can all be simplified to 1. So I can write 1 in the form of 10/10. Well, if I did that, and then added 9/10, what would the fraction be? So if I had 10/10 and added 9/10, because that's the fraction, or that's the mixed number that I have, 1 and 9/10, that would simplify to 19/10. So 1 and 9/10 written as a fraction, an improper fraction because the numerator is greater than the denominator, would be 19/10. So that tells me that positive 19/10, the absolute value of positive 19/10 is 19/10, but also the absolute value of negative 19/10 would also be 1 and 9/10. So these are both true as well. So A, B, and C, that make all of the above the correct answer. So this question is assessing you on two things as well. Do you understand the concept of absolute value, meaning that we're just looking for the distance a number is from 0? And do you understand how to change a mixed number into an improper fraction? So the answer was yes, we did. We knew how to do both of those things. Erase all these, and yeah, okay. So those are the examples that I found about GED questions that had to do with absolute value. It is simply thinking about how far a number is from 0, and in the way that plays out in the simplifying and just doing your arithmetic is that a number and the absolute value signs, whether it has, and the absolute value signs, whether it has a negative sign or a positive sign, will be treated as a positive number because distance is usually thought of as a positive number and not with a specific sign. So that's all it is to absolute value. Thanks for joining me today.